All right, welcome back to Math 160. We are going to continue working through our Unit 3 notes. We left off on page 16, that is measures of position. So my goal for today's class is for us to finish these notes and be ready for our first test. Yes, I said it. Okay, let's switch over to the notes and take a look. So we're going to start by discussing percentiles. So first off, let's note that percentiles divide the set of data into 100 equal subsets. Right? I mean, when you hear 50th percentile or 73rd percentile or 95th percentile, you're thinking percentages, right? So it would make sense that it's out of 100. The notation P sub K. So that's a P with a subscript K. So P sub K is a value such that at most K% of the data is smaller than the value P sub K, and I'll explain that in a second. So P sub K is a value such that at most K% of the data is smaller than the value P sub K. As an example, let's say that I wrote P sub 85. Okay, P sub 85. What this is referring to is the 85th percentile. This also states that at most 85% of the data will be less than that data value. Because remember, it's a position, right? It's a measure of position. So if this particular data value is in the 85th percentile, P sub 85, that means that at most 85% of the data will be less than that data value. It refers to a specific position in the data. Next, we have quartiles. When you hear quartiles, I want you to think quarters, right? First quarter, second quarter, third quarter, fourth quarter. I want you to think of, you know, how you break quarters down, 25%, 50%, 75%, 100%, right? Think of quarters. So the first note should be kind of like, okay, yeah, that makes sense. So quartiles divide a set of data into 4 equal subsets. Percentiles divides it into 100 equal subsets because it's out of 100. But quartiles divide it into 4 equal subsets because we're thinking quarters. Each subset, because it's quarters, each subset contains 25% of the data. Let's write that down. Each subset contains 25% of the data. What I find to be really helpful is to have a visual that kind of describes how you find quartiles. So if you have a straight edge, you'll want to take that out now. Just, I mean, it's up to you. It just helps me to make this solid line, and I'll explain what I'm doing in a second. So first off, I want you to think of a set of data that has, that essentially you've placed in order. So you've placed your values in order from low to high. Okay, that's what I want you to visualize, that you're placing your values from low to high, and you've essentially arranged them, right? So there you have your arranged set of data from low to high. When we are determining the quartiles, right, the positions for each of these quarters, what we want to do first is we always want to cut the data in half. So I'm going to look at my spread of data and I'm going to say, well, here's the halfway point, right? What is the value right in the middle of the set of data? Do you remember what you call it? What's the value in the middle of the set of data?
The mean.
The mean is the average of all the values. You're close.
Is it the mid-range?
Median.
The median. So the range actually takes the high, the low, and then subtracts it. So it gives you the spread of data, which is really, really helpful. But the value right smack in the middle of the set of data is actually your median. So there's a notation we learned for the median that's X with a tilde on top. If you'd like, you could simply write out median. Think in the middle of the road, right? When you're driving, the median's in the middle of the road. So median, middle, perfect. So the first thing we do is we cut that data in half. So I have a question for you. If we're discussing quartiles, which position would that be if you're cutting the data in half? What percentage are you going to have on either side of this data value?
50%.
Exactly, 50%. Yes, beautiful. So this value here in the center, this particular data value that cuts the data in half, which is also the median, is called Q2. Q2 means the second quartile. And I'm actually just going to write that out here as well. So Q2 means second quartile. And when you see second quartile, I want you to think 2 quarters, 50%. Second quartile, 2 quarters. So that's the first thing you do, right? Once you've set the data from least to greatest, you've arranged them, you cut the data in half and you say, okay, I found my median, which is also Q2, my second quartile. From there, the great thing about Q1 and Q3 is that they're essentially the halfway point between each half. You're probably like, what the hell are you saying? What I'm saying is, if you look at the lower half of the set of data and you cut it in half again, you've just separated the lower half into 2 quarters, right? Where the value of this first data value here will represent Q1, because any of the values below this represents 25% of the data. So think of this as like, here's your first quarter, right? Which is 25% of your data. Here's your second quarter. This is also 25% of the data, unless someone said, hey, what percentage of data do you have below Q2? And you would say, oh, well, I have 50% of the data. So Q1 represents the first quartile. And when you see first quartile, think 1 quarter, which is 25% of the data. And then we do the same thing for the upper half. So looking at the upper 50% of the data, cut it in half again. And that value represents Q3. Remember, it's a position, right? It's a measure of position. So a particular data value represents Q3, our third quarter. So there's 75% of the data that lies below Q3. 25% of the data lies above Q3. Has everyone seen how this whole thing works in terms of quarters of the data? Let's go ahead and write Q3, third quarter, or third quartile. And 3 quarters gives us 75%. Good. I put those notes here in case you're just looking at the notes and not rewatching the video, so that you can see that the first quartile and the 25th percentile, they've got to be the same, right? So when you think of Q1, I want you to think P25, P sub 25. So 25% of the data is lower than that particular value. For Q2, that's definitely going to be P50. And for Q3, that's going to be P75. Okay, first quarter, second quarter, third quarter. Good. Also, I've typed up how you find the quartiles. So we just had this dialogue together about ranking your values from lowest to highest, cutting the data in half, Q2, then cutting each portion, each 50%, cutting them in half again, and that gives you your first and your third quartiles. So I've typed that up here at the bottom in case you ever like, wait, how did she do that again? It's right here, how to find quartiles. You will follow those steps exactly. Okay, go ahead and turn the page when you are ready. We have some more definitions to talk about. Next, we have the mid-quartile. We've actually kind of discussed something like this when we talked about the mid-range. So with the mid-range, we took your high value and your low value, we added them and divided by 2 because we were thinking middle, right? Middle of the range. So you average them. With mid-quartile, it's the same idea, except you add the first quartile and the third quartile. Then you divide those by 2. Okay, mid-quartile, the value between Q1 and Q3. And we do that by averaging those values out. So that's something to keep in mind. Here's how you calculate the mid-quartile. We also have the interquartile range. So as we described range earlier, range is high minus low, but this time because we're talking about quartiles, when we reference interquartile range, I want you to think, well, this time we're talking about Q3, Q1, right? The Q3, 75%, the Q1, which is 25%. So all we do to find the IQR is we take Q3 and we subtract Q1. That's it. So it's similar to the range in that regard. High minus low. This time our high is Q3 and our low is Q1. The interquartile range is the range of the middle 50% of the data. But that should make sense. I'm just going to show you the diagram again. Q3 to Q1, look at this range here. This represents the middle 50% of the data, since each of these blocks represents 25%. So 25%, another 25, another 25, and your last 25. So this middle piece here is 50. Good. And lastly, we have the 5-number summary. Typically, you will see 5-number summaries with box plots. When you graph them, you will see box plots, and you can find the 5-number summary just by looking at those box plots. So I'll show you a bunch of examples, and I think you're going to like this a lot. Kind of mapping the visual to these particular values. So 5-number summary, because you will be able to identify the lowest data value, the first quartile, second quartile, third quartile, and finally your highest data value. So for your 5 numbers, you need these values, okay? It indicates how much the data are spread in each quartile. I will tell you that the spread of data can vary from quartile to quartile. Even though I gave you this visual and it looks like the quartiles have the exact same spread, that's not the case. Actually, that's typically not the case at all. So the spread of data can vary. So for instance, this could have been really, really long. So the spread of data from the lowest to the first quartile, that could have been really expansive. It doesn't have to be tight and the same for each quartile. You'll see what I mean when we look at a bunch of examples. So the spread of data can be different from quartile to quartile. Think about that for a bit, okay? Practice number 10. Use the following 20 data values to answer the questions that follow. So the first thing we want to do is we want to calculate what is the first, the second, and the third quartiles. Okay, here's how we do this. I want to walk you through this so that you feel confident about trying these in Lumen. So notice we have 20 data values. If we cut it in half, that means we have 10 and 10. So if you look at the first row, notice that I've actually listed 10 values and then 10 more values just to make your life super easy. Okay, the next thing we want to consider is, are they in order? Yes, they are, from lowest to highest. Perfect, check. Now, once we have found the fact that our values are arranged from lowest to highest, we want to find the median. We want to find our middle value. So talk to me about the median. What do you see here in this set of data? How would I find the median?
Would you add 64 and 67 and divide by 2?
Okay, so take a look at what Surujini is pointing out. For the first 10 values, we have 6.4 in the last position of the 10th, and we have 6.7 in the first position of the 10th. The reason that this is important is because since we have an even set of data, when we go in and cancel out from, left and right cancel out to find the exact middle values, we have these two. We don't have one single middle value, we have two. So Surujini says, okay, that's not a problem. If we want to calculate Q2, you're going to take 6.4, you're going to add it to 6.7, and then you're going to divide by 2. So this is going to give us the median. The median is the same as which quartile?
Second.
Yes,
Q2.
the second quartile, your Q2. Perfect. Okay, so add those two, divide by 2. What does this give you? And you can tell me your answer to the hundredths place. Yes, thank you, Abby. 6.55. Don't you love the chat? Sometimes it's so nice. It just pops right up. So Q2 is going to be 6.55. Notice that Q2, which is the median, is not an actual data value. That's not a problem, right? There's no issue there. It's okay that it's not an actual data value. Next, we want to find the first and the third quartiles. So to find the first quartile, notice that we have 20 values. So we essentially have 10 here and 10 here. So the lower half and the upper half. For the lower half, we're simply going to look at each of these values and identify the exact middle. So let's see what's happening. We have these two are gone, these two are gone, these two are gone, these two are gone. Notice that we have 6.0 appear twice. Typically, we would add these, divide by 2, but what's in between a 6.0 and a 6.0? A 6.0. So your first quartile, your Q1, is simply 6.0. Remember that Q1 is your 25th percentile, or P25. Okay, so
Do you mind if I have a question?
I love your questions. Go for it.
So what if you do 5.6 plus 6.4 and divided by 2?
Oh, I see what you're saying. So sometimes that kind of idea where you take your section of the data and then you average the lowest and the highest of that section, sometimes we get lucky and that would provide us with the middle values, but not always is that the case. It just happened to be that way for this set of data.
Okay. All right. I was just wondering.
Yeah,
Thank
no,
you.
that's a super valid question. And here's how I can prove that. If we had, for instance, 5.6s, then we have 5.8, but then we see 5.8 again, 5.8 again, 5.8 again, and then 6.1, 6.2, 6.3, 6.4. If you had added those and divided by 2, you would not get that 5.8 value.
Okay. All right. Thank you.
You're very welcome. Excellent. So again, for Q1, you would add those, divide by 2, but it's the same value, so you don't have to do that. For Q3, notice that it's going to end up being the exact same positions. So this time we want to find the exact halfway point between a 6.9 and a 7.0. So that should be 6.95, but we can prove that. So take each of these values, add them together, divide by 2, and you find that Q3, your 75th percentile, is 6.95. Okay. Any questions for me on finding the first, second, and third quartiles?
I have a question.
Yes.
So for Q3, I thought that we were going to like subtract the 7.5 to like 5.6. So how, like, I don't know why, but like, why did you add the 6.9 to 7.0?
Great question. So keep in mind that the third quartile is found by finding the halfway point of the upper half of data. I know I said like a crazy mouthful. Think of this diagram. When we had our values arranged from low to high, the first thing we did was we cut the data in half, right? And we found that median. In order to find Q1 or Q3, you have to find the median of either half. It's the halfway point again of the upper half, that's Q3, or the halfway point of the lower half, which is Q1.
Oh, I see.
This is why when I looked at these upper values, I said, okay, let's pretend that these 10 values up top don't exist and you only have the 10 values below, which means, okay, well, what's the median of these 10 values? And you go, okay, these are gone, these are gone, these are gone, these are gone. And oh, shoot, we're left with 2 in the middle. So I have to average those out.
Okay, I see.
And then you do the same thing for the top. For Q1, you find the exact middle and you average those out. That'll give you the first quartile.
So right now we are just looking for median, for the median, right? For Q3 and Q2
Yes,
and
Q2 is the median of the whole set of data,
Okay.
right? The first quartile, Q1, this is the median of the lower half of the data. Does it help if I write it that way?
Yeah.
Beautiful. Where Q3 is the median of the upper half of the data. Yeah, this is great. I'll just make these notes so that it really brings it to light. So yeah, always think you're cutting the data in half and then you are finding the medians again for the lower half and the upper half.
Okay.
Beautiful. Take a look at number 2. In what percentile is 6.2? So what we're referring to is the actual data value 6.2. So I'm just going to circle this. And if we want to figure out what percentile that data value represents, the first thing we consider is what position is 6.2? Out of this entire data set, what position is at 6.2?
The third? Repeat the third.
Actually, let's count all of our data values, right? So we would say, okay, well, 5.6 is the first and the second, 5.8 is a third, 5.9 is a fourth, 6.0 is the fifth and the sixth, then seventh, then eighth. So 6.2 is the 8th data value out of 20, right? So I'm going to write something down. We know that the value 6.2 is the 8th data value in our set. Note that we have 20 values, right? And actually, I'm going to say in our set, let's get rid of that period, out of 20 values. So to figure out what percentile 6.2 is, it would only be natural to say, well, if 6.2 is the 8th value out of 20, 8 out of 20, we suddenly have a fraction, 8 out of 20. Punch this into our calculators or reduce and notice the fraction that you result in. Punch this in, you get 0.4, which is the same as 2/5. So 0.4 as a decimal, multiply this by 100, and this represents the 40th percentile. And that's because it's 40%. So 6.2 represents the 40th percentile. We can write it using our fancy notation. We can write P sub 40 is equal to 6.2. Our 40th percentile is the value 6.2. Excellent. This is definitely something I want you to keep in mind when you're finding percentiles. You always do part over total. That'll give you your percentage. So our part, meaning 6.2 is the 8th value out of a total, which is 20 values. We do the math and we find that 6.2 is the 40th percentile. Turn the page when you're ready. Okay. What is the value of the mid-quartile? What is the value of the mid-quartile? So we're going to take a look at that for a moment. Who remembers the formula for mid-quartile? Would you just share that with everyone?
Would it be 6 point, like Q1 plus Q3 divided by 2?
Yes, excellent. That is your mid-quartile. Very nice. Perfect. Mid-quartile is Q1 plus Q3 divided by 2. That's exactly correct. We know that our Q1 was 6.0. Our Q3, if you flip back, you'll see that that was 6.95. Add those two, divide by 2. What is the value of our mid-quartile?
6.8, 6.48.
Yes, 6.48. Just for the sake of keeping all of our values, and then, you know, what we'll do is we'll keep all the values, and then if we're taking an assessment in Lumen, homework, you know, tests, whatever that may be, then we could say, all right, well, what is it looking for? Is it asking us to round to the nearest tenths, the nearest hundredths? So at least we have the full value here, and then we can say, all right, well, let's just see what the actual software is looking for. Good. Number 4, what is the interquartile range? What's the formula for interquartile range? The IQR.
Q3 minus Q1.
Perfect. Q3 minus Q1. Think high minus low, right? Interquartile. So you're looking for the middle 50%, and that runs from Q1 to Q3. Awesome. Q3 is 6.95. Q1 is 6.0, and you find that the interquartile range is 0.95. Beautiful. Very nice. We applied the formulas and we have the values that we're looking for. Earlier, I had mentioned about the 5-number summary referring to box plots, right? Or essentially, you can look at a box plot and identify that 5-number summary. So I have that information here for you. A lot of information related to box plots that I just wanted us to read together. Starin, would you start us off by reading items 1 and 2? So we have a box plot, or a box and whisker diagram. That's another name for it. And then it's a graphic representation of the 5-number summary. Starin, would you read 1 and 2?
The 5 numerical values are located on a scale, either vertical or horizontal, and the box is used to depict the middle half of the data that lies between the two.
Keep going to.
I'm sorry, I didn't see that part. Lies between the two quartiles. The lowest line of the box is Q1. The highest box line is Q3.
This is very important. The box itself, I know I haven't shown you this yet, but kind of keep this in your mind. The box itself is used to depict the middle half of the data, right? Where the lowest line of the box is Q1, and then the highest line of the box is Q3. Keep that in mind. Lucy, would you read items 3 and 4?
The line through the box represents the median or Q2. The whiskers are line segments used to depict the other half of the data. A star? Is that a
Yeah,
star?
usually you'll see like a star, a little asterisk.
Okay, indicates an outliner. Either the extreme high or low value can be considered an outliner.
Okay, the line through the box represents the median, something to keep in mind. The line through the box represents Q2, your median. And then the whiskers, again, I know I'm just saying a bunch of words and it doesn't mean anything yet, just stick with me. The whiskers are line segments used to depict the other half of the data. So these are line segments. If you see a star, like a little asterisk, you know that you have an outlier. That's how you would represent it in a box plot diagram. You would see a little star and you're like, oh shoot, I have an outlier here. That could be either a very, very, very low value that's essentially extreme from the rest of the data, or really, really high value. Beautiful. Lainey, would you read parts 5 and 6, the last two pieces here on properties of the box plot?
Yeah, the lower or left, depending on orientation, line segment represents the quarter of the data that is smaller in value than the first quartile. The upper or right, depending on orientation, line segment represents the quarter of data that is larger than the third quartile.
Beautiful. So this refers to those whiskers that we were talking about. So the lower whisker, the left whisker, represents the first quarter of the data, right? Because that's lower than Q1. The upper whisker or the right whisker represents the quarter of the data that is larger than the third quartile. It's still 25% above that Q3. So I want you to still think quartiles, okay? Beautiful. Let's turn the page and see what the heck we mean. Dun, 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 dun. Here is our first box plot. Okay, perfect. So I want you to notice here that we have a descriptive statistic that describes this box. This is grooming time in minutes. So we have our minimum value, which is 4.0. Your minimum value is right here. So notice, and if you're ever like, wait, what? First off, notice the vertical scale here. This is grooming time in minutes. And here's the spread of all of your values where we have a 5-number summary. We have our lowest value, which is here, our highest value, which is here. According to our chart above our box plot, we see that our minimum value is a 4.00. That would have been hard for us to guess. I mean, if we looked at this, we probably would have said maybe 3, maybe 2, maybe 3. The value is 4.00. So I'm just going to write that on the box plot. I find it to be helpful to write all over this stuff that we have. We have our maximum grooming time, which is 63 minutes. So we can go ahead and label that as 63. Okay, it's a long time, which is fine. there's no judgment. I don't know why I said it that way. Now, this box itself represents the middle 50% of the data. Now, remember what this said. According to our properties on the previous page, we learned that the line that goes through the box represents your median or your Q2. So the line that goes through the box is Q2, and that has a value of 18 minutes, which is our median. This is our Q2, 18 minutes. The lower line and the upper line, the lines that actually create the box, believe it or not, these values represent Q1 and Q3. So this line here represents a specific value. If we look straight across, we would say, oh, maybe it's like 33, 34, something like that. Q3, according to our chart of values, is actually 34.25 minutes. Where Q1, the lower bound of our box, has a value of 12.75 minutes. The next thing I want you to consider is the spread of data. So this is something that takes a little bit of practice, but what I'd like to do is to turn this box plot on its side. And I want you to just kind of visualize overlaying a graph, right? Overlaying a curve, whether it be skewed left, skewed right, or maybe it's symmetric, maybe it's a normal curve. Doesn't it feel like there's a very large spread of data towards the right-hand side? This is so much more spread out. On the left-hand side, everything feels very compact. It's not really spread out. Those data values are pretty tightly, they're tight together. So believe it or not, this has a similar feel to the following. Let's see if I could do this in a nice way. Here we go. Perfect. What kind of distribution do we have here?
Skewed to the right.
Yes, skewed to the right. Excellent. By looking at the box plot and seeing how spread out those values are, we can say, oh, this is a skewed to the right distribution. That's actually what we're looking at here. Now I have a question for you. What percent of the values lie above Q2?
50.
Yes. What percent of the values lie below Q2?
50.
Oh, interesting. You just told me that here's Q2. You just told me that 50% of the values, the data values, lie above and 50% of the values lie below. Do you see how the spread of data has nothing to do with the number of values that are underneath? They're the same. Q2 is your median. It cuts your data values in half. It has no indication on how spread out the data happens to be. I want you to make that connection.
I have a question.
Yes.
When you said that which percentage lies below Q2, I thought that was like 25%, but
Well,
is it 50 or 25%?
50. Q2 is 50%, right?
Right.
Yes, 2/4. So if Q2 is the median, it actually cuts the data in half, which is 50% below and 50% above. I want to really drive home the fact that even though Q2 cuts this data in half, it actually has no indication on the spread of data values. There are still 50% of the data values below. They're just really, really, really close together. It seems like the bulk of people will spend anywhere from 4 minutes to 18 minutes on getting ready, right? Half of the people will spend anywhere from 4 minutes to 18 minutes. And then the other half will spend from 18 minutes to 63 minutes. But this part is really spread out. So it's almost like, you know, you're looking at, let's say, I don't know, do we have an N here? We don't. Let's say we were looking at 50 people. Half of those people fall in this tight range from 4 minutes to 18 minutes. That's a really small window. And then the other half lies from 18 minutes to 63 minutes. And that's a much larger window, but it's still 50% of the data is below, 50% of the data is above. It has no indication on the spread of data. I hope that makes sense.
Okay. A little bit.
Beautiful. I will say that below Q1, that's 25% of the data. Right? Because Q1 represents the first quarter. So 25% of the people who are surveyed take anywhere from 4 minutes to 12.75 minutes. Okay, here's another second quartile, or excuse me, here's another 25%. So from Q1 to Q2, that's 25%. From Q2 to Q3, that's 25%. And then from Q3 to the highest value, that's another 25%. So think quarters. 1, 2, 3, 4 quarters.
I have a quick question.
Yeah.
Is this what you meant when you were showing us on the straight line that it doesn't have to be within that range?
Yes, that they don't have to be even. They don't have to be spread the same. So each quarter, notice the width of each quarter. They're all very different. The spread of values is all very different, but they still represent 25% of the data. Here's another 25. Here's another 25, and here's your final 25%. So it has nothing to do with the spread of data. They're just positions. Okay. All right. So let's go ahead and answer each of these pieces. So IQR, we know the formula because we did this on the previous page. IQR is Q3 minus Q1, the interquartile range. According to our values, interquartile range is found by taking Q3, which is 34.25 minutes, and subtracting Q1, which is 12.75 minutes. When you do the math, what do you get for your interquartile range?
21.5.
Okay, 21.5 minutes. Now, what does this IQR represent?
The middle 50%.
Perfection. The IQR represents, nicely done, the range of the middle 50% of the data. The middle 50% of the data has a range of 21.5 minutes for grooming. That's the spread of time from Q1 to Q3. It's 21.5 minutes. Go ahead and answer number 2. And don't say it out loud. I just want you to think about what we just dialogued. And I would like you to write your reasoning, because I want to make sure that you're understanding why this is the case. So if we were to draw a histogram, what would the shape be and why? And don't say it out loud. Think about our discussion here. And go ahead and write down the shape of that histogram and then explain why you believe that is the case. Just take a couple minutes to do this.
I just had to finish up the last thing on the bottom.
Right here?
Yeah.
Okay, what did you say for the shape of the histogram and why? I would love to hear your descriptions for number 2. What did you think?
I put skewed to the right because the majority of the values are in the first 50% of the data.
I like what you said, I'm going to tweak that just a tiny bit. What if you said instead that the lower 50% of the data values are much tighter together? So you may want to hint towards that idea of spread. So you could say that the lower 50% of values are really tight together and the upper 50% of the values are much more spread out. That would be a great way of showing why it's skewed to the right. Okay, I did see something in the chat. Let me open this up. That's interesting. The median is closer to the minimum value. So we feel like that is a property of being skewed to the right. That's actually a very interesting point. I would say, I would totally accept that. I would still suggest that hinting at the spread of values is going to actually be pretty helpful. So let me write down what we want to kind of lean towards. So we will say the shape would be skewed to the right. Because, and here's just one way of describing this. I like all the dialogue that we're having. Because there is more dispersion from the second quartile, or Q2, to the maximum than from the minimum to Q2. So there's more dispersion, there's more spread out data from Q2 to the max than there is from the lowest value to Q2.
I have a question about that.
Yeah.
And we only know that because the Q3 is the 34.2. It's a larger number.
Yeah, well, actually, we know that only because of the visual too. We know that because.
Oh, we're still looking at that one.
Yes. It's based on what this visual is presenting to us, a box plot.
Okay. Yeah.
Perfect. Love it. The shape would be skewed to the right because there's more dispersion from the second quartile to the maximum than from the minimum to the second quartile. That's one way to describe it. So then in which case, can I turn the page? So then in this case, which would be higher, the mean or the median? Think back to what you learned about skewed to the right distributions. What would be higher, the mean or the median?
The mean,
Yes, the mean. Why?
because there's, I don't know if they'd be outliers because how many, but the maximum's a lot higher than the median.
Yes, so what's happening to the mean? It's being pulled in that direction, right? It's being pulled in the direction of those higher values. Yes, absolutely. Very, very nice. Let's write that down. So which would be higher? The mean. And this, again, this is a property of skewed to the right distributions. It's if you go back to one of our previous pages where we look at the skewed distributions, this is just one of the properties. So the mean would be higher because it is being pulled in the direction of the much higher values. Good. Excellent work. Excellent work. What I'd like you to do now is on your own, I would like you to try part B. So based on the chart and box plot below, so based on this information here, I would like you to answer 1 and 2. So just simply answer questions 1 and 2. I'm going to pause the video and take attendance. All right, let's take a look and see how you did on this particular box plot. So when you looked at this box plot and you were thinking about the spread of data, what was the shape of your histogram? What did you say for the shape? And you can just shout it out. Aha,
Skewed.
Emma. Go ahead, someone else.
I said it was normal.
I said that skewed left as well.
Good luck.
Skewed left? Yes, skewed left is going to be correct. Notice that this value through the box plot is Q2. This is your median. Notice how much the data spread out to the left of the median versus the right. So when we think about, you know, making this overlay, you can kind of think about the fact that it's looks something like this, right? That's a bad drawing, but I want you to kind of see this curve here where it's very skewed to the left. So the shape of the distribution it would be even if the values to the left and to the right of Q2 were spread about the same, but they're not. This side is so much longer than the right side. So the data is definitely skewed to the left. So the shape of the distribution would be skewed to the left. And I'll say because the values below the median or Q2 are way more spread out. I'm sure that's not, you know, scientific, way more spread out or whatever than the values above the median. So in which case, what would be higher, or excuse me, which value would be smaller, the mean or the median? Which would be smaller?
The mean?
Yes, the mean. Excellent. Why would the mean be smaller? Because, what did you say? Why is the mean smaller? And anyone can jump in.
I was going to say, is it because it's like being pulled to like lower numbers?
Yes, yes, absolutely. That's absolutely correct. So the mean would be smaller because it is being pulled in the direction of the smaller values. Right, there's so many smaller values below Q2. The mean is definitely being pulled in that direction. Okay, so the median is obviously going to be a higher value than the mean. The mean is going to be somewhere in this area. Very nice. Again, if that's kind of throwing you off, go back to those distributions just so that you can have a visual of skewed left, skewed to the right. And then, of course, the properties associated with each. What's higher, what's lower, that kind of thing. Let's go ahead and turn the page. We're almost done. We're almost done. This is great. Okay, let's go with Anthony. Would you read the note that is there for everyone? Would you read that out loud?
When explaining if the mean or median would be higher, avoid saying it is because the majority of the data is below or above the median. Remember, the median divides the data into two equal parts. It is dispersion of the data or how spread out the data is. For example, in our skewed to the right distribution, the data would be more spread out above the median.
Thank you so much. Perfect. Keep this in mind as you're answering questions. All right, take a look at practice number 12. We're going to actually use the 5-number summary: low, Q1, Q2, Q3, high. Based on this, our variable is number of texts people receive. So check it out. If we had 80 values, how many data values would you expect to be less than 44 and a half? So let's talk about that. That value 44.5, Megan, what does that even represent in this 5-number summary? That 44.5, what does that represent?
%. I'm sorry, 50? No, 25?
Okay, Megan, what do you think? Do you agree with that? What are your thoughts? What does 44 and a half represent? According to our chart.
The first quartile.
Okay, 44 and a half is our Q1. That's the position. So what percent of the data would be less than that value? Anyone? What percent of the data would be less than Q1? Angelica says
25.
says
25%.
yes, 25%. Abby says 25%. So because it says less than 44 and a half, we know that 25% of the values are less than Q1, Q1 being the first quarter. So if you had 80 data values, you're going to say that we need to figure out what is 25% of 80. That's exactly what we're trying to figure out. It's not that we're counting the number of values that are less than 44 and a half texts. We are saying out of all of the data values, if there were 80, how many would you expect to be less than 44 and a half? So we are saying, okay, then 25% of 80. 0.25 of stands for times. We'll multiply by 80, and that gives us 20. So we can say we expect there will be 20 data values less than 44.50 texts. And remember, because we're calculating mathematically, even though the half a text doesn't make sense, it's all mathematical, so we're just using the values that we were provided. How many data values would you expect to be more than 76 and a half? Sam, tell me about that 76 and a half. What does that represent?
That's the third quartile.
Okay, so Q3 has a value of 76 and a half text messages. So Sam, what percentage of our data is above Q3?
That'd be 25%.
Yes, so guess what? It's going to be the exact same answer, except obviously we would write more than 76 and a half texts instead of less than. There's still 25% of the data above Q3. So we have 25% of 80, same exact thing. That's going to be 20 values. And we would say we expect there will be 20 data values more than 76.50 texts. Thank you so much, Sam. Holly, next it says, how many data values would you expect to be less than 56.00? So Holly, what does that 56 represent?
That would be 50%, right?
It would be 50%, and that's because 56 represents what value? That's our
Median.
Yes, that's our median. Beautiful. And yes, Holly's exactly correct. We expect 50% of the data to be lower than that value. So we are saying 50% of 80 data values. So half of 80, that's going to be 40. So we expect that 40 data values would be less than 56.00 text. Good. Very nice. Look at number 4. Turn the page. It's still based on the same chart, the same 5-number summary. So I'm just going to flip there real quick so we can look at number 4. Number 4 says, how many data values would you expect to be more than 44.5? So if you go back, what percent of the data would be above a 44.5?
50.
Just 50?
75.
Aha, 75%. So Q1 represents 25% of the data below, but we want to know above Q1. So if Q1 is 25% below, that means you have 75% above. So I'm just going to jot that down. We know this is Q1, but remember we want more than, so that represents 75% of the data. So it's 75% of 80. And how many values is that?
60.
Awesome. Thanks, Mike.
How do you get 60?
Oh, take 0.75 and then multiply it by 80. Turn that into a decimal. So there would be about 60 data values greater than 44.5 texts. Beautiful. Okay, we have about 6 minutes left of class. I believe that you have enough time to answer part B, but just in case, before you answer this, because you really could take part B home and we can look at this on Wednesday, what I'd like to do really quickly is just look at the very last page. So I want to finish by looking at the coefficient of variation, just to explain to you what this is. So the first thing is it describes a standard deviation relative to the mean. This is used when comparing variation in samples or populations with different means. It's also used when comparing the variation from two populations with different scales or units of value. So I do want to provide these formulas for you, just so that you can see what the coefficient of variation is and how it's calculated. What does that letter S represent?
Sample?
Ooh, not quite. This little s has a statistical meaning.
Is it the
Standard
standard
deviation.
deviation?
Yes, excellent.
the
This is
sample?
standard deviation. And what is X bar again?
The mean?
Yeah, the mean. So regardless of whether or not it's a sample or the population, look, sigma is standard deviation, mu represents the mean. So the coefficient of variation is found by taking the standard deviation and then dividing by the mean. I wanted you to at least have that information. Good. That concludes our Unit 3 notes. So I would love for you to take Part B home and answer questions 1 through 4 based on that 5-number summary. Okay.
Professor?
Yes, go for it.
Are all the recordings like the notes on Lumen? So if I wanted to go back and re-look at these notes?
Always, yes, absolutely.
All right, thank you.
Yeah, of course.
What's the test?
When is the test?
Yeah.
So we are actually going to decide on a due date for the test. So let me go ahead and open up the Lumen course. Let me get us in here really quickly. Give me 1 second. I'm logging in. And let's open up this one. And let me show you what's happening here. So we still have our Unit 3 homework assignments. Let me share my screen and then we can figure this out together. As it stands for Unit 3, you have 2 assignments that are due this Friday. We have measures of position and box plots. That's one more assignment, and then our application. Let's take a look at what the application assignment is for Unit 3. Notice that you are going to calculate the mean, range, variance, and standard deviation for just these 5 values. And then you're going to manipulate this data set a couple times and see what actually happens based on that manipulation. And then for numbers 4 and 5, you're essentially kind of describing which measure of central tendency you would like to use in order to do some persuasion. And that's it. Yes.
Is there still time to like catch up if we have to?
I mean, yes, for sure. My hope is that you have completed units 1 and 2 and that you're moving into Unit 3. What I would suggest is start to complete the Unit 3 homework assignments. By the way, let's come up with the due dates for these. And then if you need additional time for Units 1 or 2, I'd be willing to do that at this point. But moving forward, we really need to be behind the 8 ball. Okay.
Okay.
Really quickly, let's come up with a due date for these 2 assignments, measures of position and box plots, and then the application assignment. What are you all thinking?
Wednesday, the 6th.
All right, let's do settings. So we've got a little over a week. So 2 of the assignments in Unit 3 are due this Friday. So is next Wednesday okay for everyone for those assignments?
Yeah.
Yeah.
Beautiful. Let's update that one. And let's update this one. You'll see that it has a due date here. I also want to talk about that test. So let's do the 6th. Keep open for practice afterwards. Good. Okay, perfect. And here's your test. I will have this open on Wednesday, just to give you time to like complete your homework and stuff. So it'll be available after Wednesday, which is the 29th, and that'll open at 12 a.m. When can I assign this test? We are essentially done with Unit 3 today, but I know you still have work to do for the units. What do you think?
Are we still going to have class on Wednesday?
Oh yeah, definitely. I'm anticipating that we'll start our new unit on Wednesday, but I would be willing to answer any questions you have at the start of class on Wednesday.
I don't
So
know
it not be any day but the 13th.
Okay, so that gives us, let's see, that gives us, we got 1, 2, that gives us 2.5 weeks to take a test.
I think that's fine because then it gives us time to do the homeworks too.
Okay.
Yeah. then we
Keep
got the
in
other-
mind, that means that we will be in our next unit. So you'll be learning new stuff prior to you taking the test. But then again, it just gives you the time that you need. So is the 13th okay?
Yeah.
Yes.
Beautiful.
Well, thanks.
Okay, good. So it will open on Wednesday and it'll close 2 weeks later. Make sure you get that done as soon as you possibly can, because you don't want to wait too long. And then the material just kind of is like, oh shoot, I forgot all about it. Your videos are always in Lumen. If you go into the, you'll see an actual block in Lumen. Let me scroll up. Here it is, Zoom lecture recordings. They're all here. They've always been there. So every single class session is recorded. Today's will be recorded and pasted here within the hour. All right.
Are we gonna go over page 22 next class?
Yeah, we can start there. We can start there. And I'll
Could you
answer.
just post the notes?
Yeah, I mean, if you wanted me to, I could just fill this out, scan it, put it in Lumen. That way you have it. And then what we could do for Wednesday is we can answer any questions you have on the homework or application stuff. That way we actually
Sure.
tackle the things that you need. Does that sound good?
That works.
Awesome. All right,
Yeah.
I'll do exactly that. And then print out your next unit. Please print out unit 4 so that we're ready to continue on Wednesday. Okay?
Okay. Have a good day.
Thank you too. See everyone.
Thank you.
I have a quick question.
Professor,
Yes, Hope.
can I just use Microsoft Excel for meantime, etc.?